Okay, so this bit is the bit on alternating current, so it's 3.7.5.5 in the spec, and we are looking at how we analyze the voltages and the currents produced when we make EMF by rotating a coil in a magnetic field, which you now know the math for. This is the voltage that the kind of like AC that comes out mains electricity, so it is kind of a big deal. Now, AC that comes out mains electricity is sinusoidal, so it looks like this. They only deal with sinusoidal voltages and currents, so you don't need to worry about it. We have some things that we measure on it. So, for example, it could be current or voltage on the y-axis. Yeah, it could be current or voltage. It would look very similar, and it all kind of applies the same. And then on the x-axis, it's always time, right? You always have time on the x-axis. So this value here, the top value here, will be the peak voltage, or V0, which is the peak voltage, or it could be the peak current, I0, if it's a current time graph. We have a value here, this from the top to the bottom, this is called the peak to peak. In some cases, it's not easy to measure the peak voltage, or if you don't have a kind of like, if it's not centered, then it might be easier to measure the peak to peak and divide it by 2, because half of the peak to peak is going to be the peak voltage value, because it goes up and then it goes down. So for UK mains electricity, it goes up to plus 325 and it goes down to plus minus 325 volts. Now, the thing about that is that's not what we quote. You know, at GCSE, you learnt voltage mains electricity is 230 volts. It is, but the reality is it sometimes goes to plus 325 and minus 325. 230 is the DC equivalent voltage. So if I wanted to have the same power from DC, I would use 230 volts, which is a lot of like 1.5 volt batteries, but that's what I'd use. But the reality is that because it kind of fluctuates like this, you lose some of that maximum, and so you don't get 325 equivalent volts out, you get 230 equivalent volts out. And how you calculate that is you do this. So when people say the mains electricity voltage, they really mean the root mean square voltage. We looked at this when we did, this comes up in the kind of like thermal physics section. But this is essentially the DC equivalent power, or heating effect sometimes, but DC equivalent power, and it's the mains divided by root 2, which is like 0.7 or something. So if you do 325 divided by root 2, you'll get 230, and that's what we quote because that's what matters, the power that the potential difference can generate, despite the fact that it's fluctuating. Now, when we look at alternating currents, we use something called an oscilloscope to look at them. If you do like Google virtual oscilloscope, there's loads of them you can have a play around with. They show you the voltage. They don't show current, they show the voltage on the screen with respect to time. The thing about them is there's a little screen that you can change what each square is worth, what each kind of like Y value is worth. So sometimes it's like, and I've seen on AQA, they sometimes say, well, that's just 1 centimeter. And then that's just 1 centimeter, right? Little squares. And then they tell you like each centimeter could be 5 volts or each centimeter could be 10 volts. It's like a graph, but you don't know what the values are. There's then something sometimes called the Y voltage gain, sometimes just called the volts per division. That will tell you how far up it goes. Then there's something called the time base, or the time, and that will tell you the time. Normally the times are in milliseconds. Normally the voltages can be anything. You can sometimes turn off the time base. And then if you turned off the time base for this one, it would just be something in the middle going up and down like that if you turned off the time base, because the time allows you to spread out the waveform and see it, you know, over a period of time. They then could ask you to find out the kind of frequency or the time intervals. So you just do the time period. It's just the time for one complete wave to pass, and time is 1 divided by the frequency. And for mains electricity, you get 50 hertz. They often, I've seen a lot of questions where they show you the pictures of the oscilloscopes and you have to like take measurements from them. Often they don't center it. If I was to show you an oscilloscope, I would center it. So I would put, you know, the middle to be the middle, but often they have it shifted up or down. You can change it, but it doesn't really matter where it is. You kind of measure the number of centimeters with a ruler if you have one, or you just, if the squares are there and they're easy to read, and you can measure the peak to peak. divide it by 2 and you can calculate the VRMS. But I suggest you go on to have a play around with an oscilloscope to see what it does, because it's difficult for me to kind of explain it to you with pen and paper.